Well, I guess we'll get started probably. This is cool. I didn't know how many people to expect, and I thought it might be two, so thank you guys for coming. This is my first talk, so any feedback you have afterwards would be great, but yeah, thank you guys for coming. Can you hear me okay? Awesome. So basically, I'm going to talk about the Android X86 tablets coming out that's based on Intel's architecture. And then after that, as we wrap up, I'm going to show you a free set of tools by Intel that can be used to really dive in, profile your game and stuff like that. And that'll work across ARM and X86 tablets. So should hopefully be kind of exciting and beneficial for the future. So I'll get started here. Big Android reaching the masses. What does that mean? Well, obviously we know Android's big, right? We've got some crazy stats over here on selfies and billion text messages. 62% of the tablet market share is Android. And obviously it's important to reach the largest number of Android devices. Well, why am I up here saying that? It's because probably up until now, all the Android tablets you've used have used the ARM architecture, the same as in the iPhone and stuff. Intel now has a push, and they're taking their X86 architecture, similar to what's on the PCs, and creating tablets with those that also run Android. Those are just starting to emerge this year, but just this year alone, they're going to be doing 40 million of them, and next year it's going to be exponentially more. So hopefully by this time next year, Android tablets that are ARM and Android tablets that are X86 will just, they will just all be out there flooding the market. And so what I'm here to talk about is how do we now take your game and make sure it runs on the X86 architecture as well? Because it's very important. You know, games sell hardware, and it's very important to Intel that, or to all of us, right, that your games are going to run great on our tablets as well as the competition tablets. So the good news is Unity, we partnered with Unity and they did all the work. If you build for Android, it's going to just automatically build an APK that supports X86 and ARM. And that comes with the next version of Unity coming out, and I'm going to actually show you how easy it is. Oh, and I got to mention too, if you brought your project, we have a build suite going on where we'll just sit down with you, show you how easy it is with the newest version of Unity. And we also have hardware that you can take home and continue testing and developing on. So if you're interested, stop by our booth downstairs and we'll schedule an appointment, and me and a couple other guys are in just the room over here. So now I'm going to give you a quick live demo, if I can minimize this. I'm going to take the Angry Bots game we know and love, and this is with the new Unity Beta 4.6. It's also in any version of Unity 5. You can see I have Android selected, and then if you look at the player settings, you're going to see a new option right down here. That's awesome. Hold on. Close this. And now the screen's not mirrored. Oh, so much fun. And I can't get my mouse. There we go. Okay. Perfect. Okay. All right, so I've got a Unity here, and I'm using something you guys probably heard of, the Angry Bots demo. Go to Build Settings. It's automatically selected for Android, and just by default, it'll build what we call the FAT APK, and I'll go into those details in a few minutes. But you know, it's got the ARM and the X86 architecture in it. And we will do build and run. I've got one of the new tablets right here, and we'll let this go, and I'll just continue Well, it should just take a second. And I'll just keep this like this, so I don't change the screen over and over again. Okay, so as it goes, it creates like I said, an APK for both. And that probably, if you're a technical developer or cynical, you might be thinking, well, what does that really mean? Is it worth doing? Let's try again. Does my APK size increase? All that stuff. So this is fun. The demo effect, exactly. All right, well, we're going to try again in a minute here. All right, so real quick, let me talk about it. It does not double the APK size. All it does is it takes some native X86 code, separate library, and all the assets, all that stuff stay the same. So in the example we've used with Angry Bots, it increases by about 6 megs. So you're not going to notice significant size, but to some developers, it is a concern, because of the limitations on the Google Play Store. So you can still, using the Unity options, do what's called a slim APK, one that has just X86 support, one that has just ARM, and you can version them in the Google Play Store so it'll be transparent to the user and still be able to download the correct one. So why do we care about this? What happens to the ARM APKs that are out there right now? They will still run on all the X86 tablets, so there's not an issue with that. But they go through a recompilation method before they're launched, and you're not going to get optimal performance. So I have some examples here of an ARM version of an APK on the X86 tablets as opposed to an X86 version. And we did 2 different applications, the games that are out there right now, and then also Angry Bots. So we can look here, the application, we call application A. The ARM version, on our tablets ran at 53 frames a second. The X86 bumped up and was capped. And then more importantly, I think the power usage, the power drainage was less. So, they're going to get better battery life. You're not going to burn up their hands, things like that. Here's another example with Angry Bots. And then this is the biggest one. This is a fairly popular game out there right now, and it was chugging along at 17 frames a second. They upgraded Unity, pushed a new APK out. It went up significantly, and the power load went down significantly, which was really awesome. And then also load times. It's using the load times are much better too. So you can see we got anywhere from a 20% to 60% load time. And now it's time for that live demo again. Let's see if it can work. I'll restart Unity. And then I'll take you straight into the cool profiling tools. Cross our fingers here. While we're waiting, are there any questions so far? Yes, sir.
What's the frame rate on just your standard sort of Nexus 7 compared to an Intel version of an ARM game?
Right, that's an Intel version. So do you mean running?
Intel tablet and you're running on an older ARM compiled thing. Is it like significantly slower than like an official ARM chip, or is it still playable?
You mean running the ARM APK on the Intel device, or do you mean just hardware to hardware?
Just like a non-optimized for Intel tablet, are they still playable, like the ARM version?
Yeah, so, well, it depends on the game. I would say in almost every case, yes, and the user will never know, but it drains the battery and stuff more. There's been some, like the one I showed you there. We're going to hold this down for a second. All right, well, I don't know what's up with my PC, and that's embarrassing because I built it this morning just to make sure it would all work. However, I can still go into our Cool Tools demo, and I'll show you that. Where is that? Okay, so the tools are called Intel Indy, and the main tool we're going to look at is called the Graphics Performance Analyzer. I've got the website right there. I can also give you the information later. It'll work on X86 and ARM, and let me run it here for you. So have you guys used the profiler in Unity much for your game? A little bit? Okay. All right, so when you start up here, it's going to notice your Android device, and then you can connect to it. And it's going to show you all your games on it, anything you want to kind of investigate and debug. So I'm going to scroll down here, and I'm going to take Angry Bots. And just as proof, I did build it earlier and it's running on here. I don't know why it didn't work again. But by default, it brings up some graphs. This is very similar to what you'll see with the Unity profiler. You can look at your CPU usage load. You can look at the power being used. You can look at all these metrics and drag them over. This is hard to do without the mouse, but we're going to do it. You can also look at the OpenGL stuff. Look at the frame per second. Pretty cool stuff. Similar to Unity Profiler, it gives you a high-level view of what's going on. But then the power is you can take a screenshot. Now what this is going to do is going to record all the OpenGL stuff for the entire frame. Then we're going to load another tool that allows you really to break down and analyze what's going on in that frame. Yes, I'm sorry. I wish you guys could see that. Yeah, it's running right here. Thank you. So these are all the frame captures we've taken. We'll take this. We're going to open it up. A little bit of waiting. Okay, now it took an entire frame cap of Angry Bots, and it's showing us tons of information, some very detailed, some very easy stuff to kind of look in and see what's going on too. What we're looking at on the big top bar is each one of these is a draw call, essentially. So those are all the draw calls going to OpenGL. On the left-hand side, we have all the different render targets used for that frame. Okay, so in some games, like if you ran this with, say, World of Warcraft, you're going to look at 20 or 30 render targets. With Angry Bots, it's just 2 render targets. First one is the first one, it looks like, is using a reflection map. So down here, you can see what the end result, composited result of that render target is. And then here's this composited result of this render target, the one that gets put to color buffer. Now, what can you do with all this stuff? The top bar here, this is, as I said, this is every draw call, and I have it sorted. I have the metrics shown us GPU duration, so you can get a sense of how long each call is taking on the GPU. And then up here, it'll tell you how long the total frame takes, 11 milliseconds, top right corner, which is 87 frames a second. So it's a good, this game probably doesn't need to be profiled, but it's a great example for me to show you. So I don't know. A common thing we see in games a lot are textures. Texture sizes, they're not compressed or they're too big. One great example is we'll find textures that are 4096 by 4096, but it's really to map or really to put on a tiny little wheel of a car or something. Something that'll never be used, but artists, bless them, they want the best quality looking things they can. So they will give you big textures. So what you can do is you can look at these draw calls that took a while. I click on this one. You can click texture, And it's going to show you every single texture that was bound on the GPU for that draw call. And it show you the details, as this one, 32 by 32, 512 by 512. So you can quickly look down if you have a draw call that's super long. In my example, I was profiling something at work. Draw call super long time, and it turned out they're using 4096 by 4096 textures, and that was I would not have caught that otherwise. So it was really easy to click on this, see that, talk to the artist, and get them down to something much more reasonable. There's a lot of neat stuff to play around with here. You can look at the actual shader. Now I know Unity uses the intermediate shader language. This is going to show you the GLSL that's generated from it. You can kind of see what's going on. If you're technical and interested in that stuff, you can even modify the shader here, play around with it, and then it'll change the result that you'll see in the render target that we're looking at. You can also do experiments. So let's say, for example, that you don't know if you want, maybe you're texture bound, maybe you're using too much texture bandwidth. You can tell it, hey, I want to substitute everything for small 2x2 textures. It's going to recompile the frame, go through it, show you the 2x2 texture result, and then show you in the top right-hand corner the delta of that. CPU go up, or sorry, GPU usage go up, GPU usage go down, etc. And then, right here you can look at the overview. How long is this frame taken? It's taken 11 milliseconds. You can when you make changes, like come over here and I'm going to choose disable. I'm going to completely disable this draw call. See what changes. The frame overview will then give an update. The red things got worse, which is funny because I disabled the draw call. You'd expect them all to be green. But the green shows you the things that improve. The red shows you things that are worse. One interesting real life fact I found here is this one. This takes a significant amount of time compared to everybody else. Well, what is this? If you go over here to the API log, it shows you, okay, this is a clear call. It's a GI clear. Now this makes sense because if I choose this render target, it's highlighting these are all the draw calls used during this render target, right? And so this is the first one, so it makes sense that they're going to clear the buffer. Well, I look down at the composite frame. It doesn't look like the buffer needs to be cleared, at least the color buffer, because it looks like every single pixel is being covered. So I was able to come over here and it's like, okay, well, what if we just, disable that? What does it do to the frame rate? If that call goes away, we bump up to 120 frames a second. I think it saved like almost 3 milliseconds. We can look at frame overview. It's a super cool way, if we're, most of these apps you're gonna use because of all the pixels on these devices, most of these apps are gonna be really fill rate bound. So anything you can do to lessen the fill rate is you're going to get a good return on investment. And so in this example there, it saved us a full 3 milliseconds just by removing the clear. Nothing else had to change. You can also change how these metrics are sorted. So if you come down here, you can say, hey, I want to look at the primitive count for Y. So on the x-axis still, we're at GPU duration for each draw call, which is how long it takes. But the top bar is how many primitives are being used. And so we look, and I was actually using one game, and I've never run across this before, but they had so many triangles that were being clipped later on. It turned out it was just bound by fetching all those verts and bringing them up to the vertex shader, not even fill rate bound, which was really surprising. And so I was able to look at these things, and you can come down and look at, well, what geometry is being used during this call. So you click on here and go to geometry, and it shows you. Okay, that's the character, that makes sense. But it's an awesome way to be able to debug what the triangles are, primitives, probably triangles being sent up to the GPU. And if there's anything that looks, obscene or that can be adjusted. So I won't go into any more details with this, but what's awesome is this is a completely free tool. It works across all the Android devices. It'll also work on PC if you have a PC game. And you can get tons of useful information without needing to add a bunch of debugging code to print out texture sizes and frame times and all that stuff. It's when I joined Intel, I first saw this tool and I thought, this is amazing. This is like what we used to have on the Xbox when I used to do Xbox stuff. So super cool, super helpful. All right, that was a live demo. And then the conclusion we come to is if you update to the latest version of Unity, it's going to be 4.6, or the next 4.6 to come out. It's going to just support Android X86 by default. You don't need to do anything. The tools I just showed you can download on software.intel.com. Just search for Graphics Performance Analyzer or search for Indy. That's the tool suite. It's free up to a much more pricey one, but everything I've showed you comes with the free version. It's not a trial, it's just free to use. And then our hopes is you have fun optimizing your apps and you just get them out there for as many Android devices as you can. That's it. Are there any questions?
So does that work on the ARM tablets as well?
Yes, sir. Yeah, so it works completely on the ARM tablets. There are a few metrics that we've put in our drivers for our hardware that can give it some additional information, but you'll still get the overview and be able to see most of the stuff, the textures, things like that, using the ARM. Yes, sir?
Does instrumentation happen at the OpenGL core level in the drive? Is that possible to compare it from the start?
I'm sorry, the question was, how does it?
No, is the instrumentation at the OpenGL level or is it lower down the drive?
Gotcha. It's at the user mode driver level is where it starts, so right at the OpenGL calls. Cool. Well, yes.
One last question. And so when you run those experiments, is that sending data across to the device and running it on the device's GPU?
Yeah, I wish I could have held this up before so you could see that. But yeah, it actually throws it on the device and runs everything through the device again. Technically what happens is when you connect to it using the system analyzer I showed you, it throws something over here and uses GDB to go back and forth and debug and runs everything through our driver again. You know, since we're talking about this, I want to show you one thing that I forgot that is super cool for just runtimes as well. So I'm loading up System Analyzer again. This is the program I used to take the frame cap that we were then able to analyze. And I'll show you, you can actually do a lot of stuff in real time to your application if you just need some quick answers and don't want to spend a lot of time trying to debug. But I don't have 3 hands, so I have to put it back down and come over here. And I accidentally decided to profile the camera. It's also fun because this will work on any games. If your device is rooted, it'll work on any games. So it's neat to see what other people are doing, how they use their textures, their render targets. As I said, even on the PC, you can use this and see what World of Warcraft is doing. Super cool. Anyway, so you can see it's running on the device, right? And then what you can come down here is say your frame rate is low. You can run some experiments. Where are they? Because my resolution is too low. Oh, well, I can't bring them up right now. But anyway, you can tell it, you know, I want to look at this with only 2x2 textures. It'll intercept all the OpenGL draw calls and replace everything with 2x2 textures. And you can look at the performance in real time. Super, super helpful stuff. But I can't seem to do that now. Also, if you want to test with lower CPU, you can actually throttle your CPU down or up, which is really great to kind of check on lower end devices. It doesn't do anything to the GPU, but still you can check and see what's going on with the CPU if you may be CPU bound at all. So yeah, any other questions? Yes, sir.
One last one. When you do the experiment and show you the different deltas between the two things, can you, if you need to do an experiment that's a bit more involved, like involve changing your code, can you load up 2 separate captures and compare them?
We have asked for that many times, and it's not a trivial problem for them to solve because it's running it through the hardware. Right. But the request is definitely in there because that would be amazing to be able to do like a beyond compare or something of the two. Yeah.
Just you can see that, oh yeah, my profiling actually didn't look
Yeah, exactly. So I just use the Windows 8 snippet tool and take a screenshot, but that would be awesome. And I know it's heavily requested. So, yes?
Does this only run on Windows?
Oh, excellent question. So it's almost all of it runs for Mac. The system analyzer I showed you, the one where we're actually analyzing graphics frame, not yet, but the Mac version is in development. So it does run great on Parallels though. So if you have Parallels on your Mac, it'll run.
Also, how much overhead is there in capture?
That's a good question. There's not much. They aim, they aim for as little as possible. In experience, it's below 10%. I think we're looking at 3 to 5%. But the good thing is too, it is all relative. So you look at your frame rate while you're running it, and then you make changes, and the relative increase you get will be the same for your game when it's not being profiled. Okay, well, just real quick, I just want to remind you, we do have our build suite. We're just hanging out in there all day. We'd love to just talk to you about your game. If you brought it, we can put it on the hardware for you and give you some hardware to take home and keep testing on. Just go downstairs to the Intel booth and you'll see Mitch will probably be there or some other guys we work with, and they can set you up with a time and we can hang out. So. Awesome. Well, thank you guys for coming. I'd love your feedback afterwards. And, I appreciate your time. Thank you.